Welcome to all. This is question 104. See, class means I will tell something. This is the last question for application of, not application actually, okay, you can tell application of calculation of moment of inertia dedicated to steel structures. Closing class. Next class onwards, we will not get this CYY given RSJ, nothing will be there. Next, you continue this in the steel structures only. Okay. The cross section, but remember, make a note. This question will give you more and more concepts, powerful question. Some hidden concepts are there, not hidden actually, important. Okay. The cross section of a gantry girder. What is gantry girder? Where it is used? See, briefly I told last time, no. That all you worry later. For those who are studying engineering mechanics, it is a cross section of a member. Okay. Consists of a RSJ ISMB 500, comma, a channel ISMC 400 and a flange plate 250 by 32 as shown in figure. See, this is I section. Remember, this is the RSJ. This is a line diagram. See, this is RSJ. This is the channel. See, the channel is turned here. Actually, above this one, rails will be there where your crane girder will move. Crane girder will move, crab will be there. A crab will be there in the crane girder. Don't worry about those things. Okay. It's a plate, symmetrical. Okay. Right. Find IXX and IYY, or find moment of inertia about centroid of the axis for the last time in the series of questions for steel structures. Okay. Properties of RSJ. See, this I section, they are told, the tick they are given. XX, YY. Breadth of flange. See, this is breadth of flange, 180. Thickness of these flanges, 17.2. This web thickness, 10.2. Total area of the RSJ. See, only area of the RSJ. See, 11074 mm square. So, for the RSJ, see, I about XX axis. Where is XX? Exactly midway. Given, IYY given. Okay, this is the property of this middle member, RSJ. You can make a small note if you want. See, this is your RSJ. They won't give. This is your channel. And property of channel, see, remember, make a note. Channel is given here this way, but the properties are not given this way. See, IS handbook, when they print properties, they always consider channel like this. So this channel is actually turned. Turning you have to account in the calculation. So they told this way, see, channel, if the channel is like this, then breadth of flange, 100. Thickness of flange, 15.3. This web thickness, 8.6. See, XX is exactly midway. Whatever height is there, midway. But YY, there is no symmetry. This is CYY. Centroidal distance of YY, 24.2. Then I about XX, I about YY given. Okay, now, this all I am removing now. Make a note. See, draw a neat cross section. See here. I tried as neat as possible. Channel, see, turn somewhat to scale. See, channel, this is RSJ, this is the plate. Channel, I have used green color today. Today, green color is channel. Black color is for RSJ. Rectangle, any color will do. So, green color is 1, that is ISMC 400. Then, black color is ISMB 500. This is a rectangle. Okay, now, when I write property in the solution, see, this is given. Neatly, I will put the chart. First, I will, see, my order is 1 is channel, 2 is RSJ. See here, I have done 2 RSJ, 3 plate. So, when I write property, they have given RSJ first, no problem. We will write first the property for channel, because why? In the order, first we are using channel number 1. Okay, see, this channel, it is given here, this way. This is breadth of flange, given in the question. Thickness of flange, thickness of web, YYXX, if the placement is like this, but here it is turned by 90 degrees, properties are given this way. See, TW, see, this TW is important. For some reason, it is important. Thickness of flange I wrote here, CYY, and area IXX, IYY. Then properties for RSJ. Once again, see, XXYY, properties from RSJ, see, whatever given here, I copied here, whatever channel given, I copied there. Now it is ready for calculation. Now first of all, make a note correctly. See, this section is perfectly symmetrical about YY. You should make a note. Oh, this I will remove now. These are all not required now. See, none of them required. I should know up to where I can write, because I turned the camera too much on the right side. I think most probably up to here, no problem. Red color, I put red color boundary. I can write to the right of the red color most probably. Up to here, no problem. I think I'll check once. Because later problem, once I write, if space is not there. Okay, perfectly okay. Okay, now this all I will remove. Question already over. I will explain the section for you. See, powerful question. Everything is transferred. Now nothing is there. Now only calculation part. Okay, start. Now write the cross section. All dimension millimeter. See here. Channel is like this. See, this total width, this distance is nothing but this distance. See, this one. Channel is ISMC 400. So I told you already so many times that a number itself is H. So remember, if you want H, here it is nothing but 400 millimeter. Same way here. In case you want the H here, I told you H here is the number 500 millimeter. Okay, make a note. Therefore, see here, this is 400. This is this width of flange. How much? BF 100. It is not required. I will not write which are not required. I will not write. Okay, then this web thickness is required for some reason. See, for some reason you can make out later. Web this is the thickness of web. This thickness is this thickness. TW, how much? 8.6, I wrote here. So 8.6 actually is a property of the channel. I will use green color. It is property of the channel, 8.6. Okay, then I section from here, see, from here, top edge to bottom edge, full depth is 500. That is from here to here is 500. Plate is 32, width 250. So the overall depth will be 32 plus 500 plus 8.6. You make a note here. Note the overall depth is plate thickness 32 plus depth of section of the I section 500 plus this thickness, how much? 8.6. 8.6. That is thickness of web for the channel. It will come to 540.6. I wrote here, see, 540.6 overall dimension. Okay. This is 250 over. Now, you have to locate for centroid. See, first here. To locate centroid. G. Before that, make a note. Perfectly symmetrical about YY axis. So, YY will come here. Therefore, symmetrical. Therefore, you write YY, you need not locate using calculation. YY is direct. Direct means, see, when YY is not required to be located by calculation, which calculation? YY is located using X bar, thousands of time I am telling. Therefore, X bar is not required. Or, if I do from here to centroid is 400 by 2, 400 by 2, here 250 by 2, 250 by 2. Okay, X bar not required. But there is no symmetrical horizontal axis. Therefore, XX is not axis of symmetry, not symmetry axis. Therefore, XX is to be located using Y bar calculation. So, to locate centroid, you require only Y bar required. Make a note, only Y bar required. Start. Take reference line. Y bar means vertical distance. Take from a reference bottom side. See here. You use black color today. Green is specially meant here. Black color. Okay. This is the baseline. AB. You take AB. Right here. Consider, you write, consider bottommost edge AB as reference axis. Consider bottommost edge AB as reference axis for finding y bar. Right, correctly. Y bar. Then y bar from where? From AB, how? Upward, equal to A1y1 plus A2y2, I should not give all this, plus A3y3 divided by total area. Okay, therefore do one thing, before you start calculating, first find total area. Okay, first do one thing, calculate total area. Total area is A1 plus A2 plus A3 because you require later also. A1, area of the channel, see here, 6293. 6293 is area of 1. A1 means first one plus A2, area of the I section, 11074. 11074, you write here, area of the channel, that is 1, first part here. Area of the I section plus area of the rectangle, somebody studying high school will do it, 250 by 32. Total area, this will come, the total area will come. How much is there? I noted 25367. 25367 millimeter square is the total area. Remember now, total area is 25367. To save the time, I will make a note here. Okay, now start. Remove this one. Start. A1y1 equal to, see here, correctly. A1, area of the channel. Before that one, mark centroid, see here. Centroid of rectangle, centroid I section, very easier. Why? Center, exactly midway. See, centroid of channel, be very careful. Green color, see. This is your centroid of the channel, G2. This is G1, this is G. G means G for 1. This is your G, see, black color. This is your G for the I section, G for 2. See, G for channel is, see, from this edge to this side by CYY 24 point, where is it? 24.2 millimeter. So here, this way 24.2. If it is that way 24.2, it is this way here. See, this web thickness is 8.6. So it will come further down. See now, make a note. See, regarding G1, make a note. Thickness of web of channel is this distance plus thickness of flange of RSJ is, thickness of web of the channel is, see, these are a small file, 8.6 millimeter. Thickness of flange of the RSJ, this thickness is, where is it? Thickness of flange here, see, 17.2 millimeter. Correct? Yes, 17.2 millimeter. So these two together is 17.2 plus 8.6 is 25.8 millimeter. So from here, top edge, if you come up to see 8.6 plus this is 17.2. So from here to here is 25.8. You make a note here that from the top edge, if you cover the thickness of the web of the channel and also cover the flange thickness of the RSJ, distance covered is 25.8. But centroid is at one distance 24.2, means it is slightly above this point. So this is green color, G1, centroid for the channel, but lies in the flange of the RSJ. See here, this G1, don't see this one. When you see G1, see, this from here to here, see, here to here is, this distance is 24.2. So it will cross the web. See here, it will, web thickness is 8.6. So 8.6, little further more. How much more not required? So, but it lies slightly above. Make this note. Okay, sufficient. Now start. A1 equal I put later. Okay, I don't know space. Area of the channel, how much it is? 6293. Space problem is there. 6293A1 into Y1. Distance of centroid of the channel from bottom edge. See here, from bottom edge is, see here, from here to here is, go for full depth first, 540.6 minus, see, we want centroid G1 distance from bottom edge. So 540.6 minus 8.6, not over, minus this distance. Someone told me that way. No, don't do that way. Directly right here. 540.6 minus from here to here. See, from here to here will be this distance, including everything. See here. This distance is this distance. How much it is? 24.2 millimeter. Someone told earlier. How much means? They will tell, sir, 540.6 minus 8.6. Okay, minus how much? Sir, minus that is 24.2 minus 8. What you are doing? Directly write 540.6 minus from here to centroid here is, see, this distance is this distance 24.2. Directly 540.6 minus 24 point, how much it is? 2. Okay, A1 Y1 plus A2, area of the RSJ 11074. See, a space problem is there. I'll go here. Okay. Here I write. That's what 6293. 6293 A1 into Y1 is 540.6 minus 24.2 A1 Y1 plus, you write horizontally, here space problem, I am writing one below other one, plus 24, A2, 11074, 11074 A2 into Y2. Y2 is centroid G2 from here is 32 plus, this is full is 500. Centroid is midpoint, so 32 plus 500 by 2. 32 plus 500 by 2, A2 by 2 plus A3 rectangle 250 into 32 is last area A3 into Y3 is this centroid from here is directly 32 by 2. 32 by 2, this total divided by the total area is 25367 is the area total. This answer will come, see, I already calculated before the class. Answer will come. I calculated that. I am here from bottom 256.261 2610163. See, I will tell you why so much accuracy I am doing it. Only for understanding purpose. Okay, over. Now you can look at, okay, or only for understanding. Only for understanding this question, understanding purpose. Right here, instead of finding Y bar from bottom edge, if we find Y bar from top edge, okay, give some name. For example, CD. Instead of AB, you call this a CD edge, top edge, CD. Suppose you from Y bar, if you do from CD, then the formula Y bar from CD will be downside equal to, formula is same right there. Why should I write once again? Okay, A1 Y1 plus A2 Y2 plus A3 Y3 divided by total area equal to, see here, A1, area of the channel, how much it is? From top if you are doing, area of channel, 6293. 6293 is the area of the channel into Y1. Its centroid from the top edge. This is directly equal to your 24.2 into 24.2 plus A2. This I section area, where is it? 11074. 11074 is the I section area into its centroid from the top edge is, see here, first from here you have to come here 8.6 down. That's very important. See, you come down by 8.6, then you reach here, then come down by exactly midpoint of 500. 8.6 plus 500 by 2 plus A3 is rectangle area 250 into 32 is the area multiplied by its centroid from the top edge is 540.6 minus half of 32. This I will not explain. 32 divided by total area is same. It is equal divided by 25367. 25367. Correct? Yes. Answer will come. I write the answer here. I will calculate the answer. I note it down. 284.3389. Okay. From the bottom edge you got 256.2610163. From the top edge you got 284.3389837. You got the answer. Now, if you add these two, you have to get back 540.6. Add it. Check. Yes, it is 540.6. I clearly checked it. Don't worry. Confidence. Okay, but remember, understanding. But actually, when you calculate, you don't do only one of them. This is sufficient. This is not required. Not required. Once you get y bar from bottom, you automatically get from top. Don't waste time. This is only for understanding for this question. So now I'll do one thing now. From bottom you got how much? 256.261, or third decimal sufficient for me. I will take this as 250. I'll write here. This I will take it as this y bar. I will take 256.261 is sufficient for me. Okay. You got the location of centroid. Now do one thing. Correctly mark. See, okay, this I am removing now. Now you are going to moment of inertia calculation. Oh, the answer is there. Okay, okay. I rubbed everything, but still luckily I got the answer here. See, otherwise I have to once again calculate now, see? Because I noted down the answer. Okay, now do one thing. Correctly mark. See, from bottom you got how much? 256.261 you got. So this is 32. So further you have to go. From the bottom edge to centroid of the I section is very, very important. From the bottom edge, see, the G2 is slightly above, I think. Okay, okay. Okay, now okay. From bottom to center of I section is 32. 32 plus 500 by 2 is 282. But how much you got? 256 you got. Therefore, the centroid is slightly below G2. See, it is here. Slightly below G2. X axis comes here. From the bottom edge up to here is 256.261. Then from the top edge, it will be 284.339. 339. Okay, over. Located now. Now, this is x axis. Due to symmetry, y will exactly pass through G3, G1, and also will pass through G2, and also will pass through what? G3. This is y. Right here. Once you write y, if you want, you can do one thing. Not required. Okay, this I will here. Space problem. This is your channel 1. Right here. This is ISMC 400. This is your 1. Okay, I remove this one here. Now, if you want, see, if you want from here to here and from here to here, you can write the answers here. 400 means 200, 200. If you require, same way here. Y, come down little. Y. If you want here, this is 125. This also 125. Okay. Now, right, we are ready for calculation of moment of inertia about xx and yy. That is, you have to find I about xx and I about yy. Okay, right. Do the formalities first. Formalities. I won't explain now. Sorry. I about any axis equal to usual statement, thousands of times told, Ig plus area into h square. Okay. This you write everything and now correctly find I about xx and yy. Start. I will start here. I about xx. 1 minute. To save the time, I will just pause a little. Just a minute. Start. I paused and stopped the recording. Only one purpose. I thought that to save the time, let me write everything. But then I remembered, this is not a very long class, last class. So this class, I decided to write in front of you only, so that you should know how to write. See, if I write everything on the board, it will be crystal clear because I always explain everything. But writing in front of you will give more confidence. Okay, start. Ixx. First, equal Ixx calculation. Okay. Ixx for Ixx. Right here. Calculation of Ixx. First, I about xx for 1. For part number 1. That is green color. Okay. Actually, green color not required. Understood. Ixx for that green color part. That much sufficient. I use green color only for that one. Ixx for 1. And this is also black color. Where is the green? No, see. In time I won't get the pen. I don't know, I misplaced somewhere. I got it. Okay. Ixx for 1. 1. Okay. Equal to, see correctly now. Equal to, but right. Come here. Come to centroid of the channel, G1. See here. Consider axis passing through centroid and parallel to xx. See, light line here. See. This axis. I about this axis. See, this axis is same as this axis. This all I told last time. Whenever a rolled section is turned, when you place it, every horizontal dimension there is vertical dimension here. Every vertical dimension there is horizontal. Whatever is xx there is for yy here. Whatever yy is there for xx. So, this all I told earlier. So, I about its own center of the axis. It is here. How much? See, this axis is not xx, it is yy axis. How much? 504.8. See, it is 504.8 into 10 to the power 4 Ig plus area. Area is 6293 is the area into red color, why important term, into, see, from centroid of the component to xx. See, this is G1. Okay. I already wrote G1 there. Okay, G1. Okay, G1. From centroid G1 to xx, see, this distance square. See, correct here. This distance square is 284.339. Subtract whatever is distance from here to here. Distance from here to here, this distance is, see, this distance, 24.2, green color, 24.2, green color value, that's all. Close square will give Ixx. Take your calculator and write whatever value you got. Don't waste time. Calculate the answer, write it. Okay, then calculate I about xx for black color one. Now color is not required. 2 for 2. Start. First come to G2. I about its own centroidal axis parallel to xx. This axis is nothing but this axis. See, that is 45218.3, 45218.3, 10 to the power 4 is Ig, plus area is 11074 is the area, into, see, powerful term now, into from centroid G2 to xx, see, this distance square. This distance is 284.339, be careful, 284.339, this full distance, subtract this distance. That is a property of the green property of a channel. Subtract which one? Subtract, where is the green color pen? Too many pens are there in that. Subtract, see, we want from G2 to here is this total distance, subtract this one, that is 8.6. Subtract 8.6. Again subtract from here to center is total 500 is 500 by 2. That is the black color. Minus 500 by 2. That one, see, this is to understand only. By 2 whole square. Calculate. Okay. Next, IXX for 3. 3 is a rectangle. First of all, I should not do anything. If I will not explain, sorry, I about its own axis. I will murmur and tell. 250 into 32 cube by 12. If this is not clear, that means you are not studying anything from my class. Better continue. Better not continue. Plus area. 250 into 32 is the area into from centroid G3 to x-axis, this distance is 256.261 minus 32 by 2. 32 by 2 whole square. If this is not clear, your complete studying from my class is waste of time. Okay, over. Now, do the needful. Do the needful. What is the needful? If somebody will ask, I will tell no needful, nothing. If someone has a doubt, sir, what is that needful you have to do? Nothing. You have to stop studying from my class. If what is the needful now, if someone will ask, sir, what is that needful? Nothing. Sorry, by mistake I told you the needful. No, nothing required for you. I will talk that way only. Because after so many, I am arranging the pen actually. After so many explanations, if somebody is still getting confused, what is that needful? Not fit to study anything from my class. Okay, over. Now, I about YY. Sometimes harsh language is required. I about YY. Okay, start. I about YY for 1. 1 is green color. See, for 1 I require. Little later I require I about YY for 2. This is too much of confusion for color confusion for me. Okay, for 2, and then I about YY for 3. For 3 equal to. Start. First channel. See, most important channel. Green color. Goodbye now. See, I about YY. So come to G1. Axis passing through G1. Parallel, that is nothing but same axis. See, remember, your G1 lies in the YY axis. Therefore, IG plus A square, distance of G1 lies in YY means H is 0. This is told thousands of times. Okay, start. I about its own axis. See, its own axis. This axis is not this axis, it is this axis. How much? 15082.8 IG, 15082.8, 10 to the power 4 is IG, plus area is, where is the area? Green only, green area. 6293 is the area, 6293 is the area into how much? Into 0 square. If someone gets doubt why 0 square means, again same thing I will tell. My class is not useful for you. You study from a better person. Okay, over. YY for 2. See, come, G2. I above, see here. Here also, its own centroidal axis passing to G2 coincides with YY, or G2 lies in YY. Here also 0 square. Even here also 0 square. Okay, start. First, I about its own axis. This axis for I section is YY only. See, this axis. 1369.8. It is 1369.8 69.8 10 to the power 4 Ig plus area 11074 is the area into once again into 0 square. Lastly, I about yy for the rectangle. This I should not explain. 32 into 250 cube by 12. 32 into, because there is a limit for everything. Cube by 12 Ig plus area 32 into 250 is the area into once again what I told earlier 0 square. You find each value and then lastly do the needful. Do the needful. What needful? Nothing. Don't do anything. That's all. Okay. Now this is a closing part of classes moment of inertia calculation dedicated to steel structures. Today's is actually part F, I think. So total 6 A, B, C, D, E, F. 6 classes are over. So many applications are considered here. These are all the classes under the title what? Dedicated to steel structure is meant for steel structures. Very useful when you study, when you go for design of steel structure subject. So others all just understand whatever is possible. From next class, remember, next class, we once again back to old part. That is what? Now once again, rectangle, triangle, then trapeziums, or what do you get? Semicircle, quadrant, so many components, dividing into parts, etc., etc. Same thing, I may start from tomorrow, exercise problems. I decided, like centroid problem, as much as possible I'll do one thing, which example I took for example for locating centroid as example for exercise, better take same example for finding moment of inertia. And I can tell centroid location, you go and study there. You study there and come back. That I will tell. I will give instruction or information when I start next one. Still not decided, but one thing, moment of inertia, few more classes are left. Maybe around 6, 7 or 8 classes are left for moment of inertia. Okay. I think today's is class number 98 or 99, I think. See, so centroid moment of inertia, question number in centroid already crossed century. Again, moment of inertia also is already crossed century. So double century over problems. And the number of classes also is about touch century now. Another 1 or 2 classes will go beyond century. Okay. Once moment of inertia is over, I will take up the last part of the engineering mechanics, that is friction. Actually, for structural engineering knowledge, only one class required. If my class is meant only for structural engineering, just one class, but I decided I will consider the subject in such a way that, see, disturbance is there, some disturbance, such a way that it is useful. Oh, what is the sound? Not only for structural engineering, not only means it is useful, but also for general public who want to study engineering mechanics for examination purpose. So friction also, I will take more classes. Number of questions there also may cross 50, 60. But subject point of view, first I will take up the important part of friction which is required for structural engineering. Then I will continue for other part. Okay. I forgot one thing here. See, sometimes I forget here. This intersection is centroid G for the entire cross section. Okay, that's all. So use these classes for steel structures, for which will help you a lot when you study steel structures. Okay, thank you. We'll meet next time.